Consider the situation shown in the figure. Calculate the acceleration of 1 kg blocks, the tension in the string connecting the 1 kg blocks, and the tension in the string attached to 0.5 kg block. Here, these two blocks have masses 1 kg, 1 kg each, and this block has mass 0.5 kg. We have to find out this tension and this tension. And also we have to find out the acceleration of each block. So suppose acceleration is in this direction, it is A. So we can consider the motion of each block separately. So let's consider the motion of 0.5 kg block. So its weight is acting in downward direction and its tension is in upward direction. So we can say if this block is going downward with acceleration A, so we can say that 0.5 times 10 means its weight minus tension upward minus tension is net force due to which the object of 0.5 kg mass is moving in downward direction. So this can be further simplified. So we can write it as 1 by 2, 10 upon 2, after this will become 5, yet we can write it such a way so that there may not be friction. So this will be 1 by 2a. We multiply each term by 2 and we will get 10 minus 2t1 equal to a. This is equation number 1. Now we consider the motion of this block. Friction coefficient in each case is given as 0.2. So here friction is 0.2. Sorry, friction coefficient is 0.2. So here there is tension T2 in this direction and its friction will act in this direction. And the value of friction Fr will be mu mg. So mu is 0.2, m is 1 kg, g is 10. So this will become 2 Newton. Now, since block is moving in rightward direction, so we can say T2 is greater than friction. So T2 minus friction is equal to MA, M is 1, so just A. And friction is 2 Newton, so we can say T2 minus 2 equal to A. This is second equation. Now, we consider the motion of this block. Suppose this is M2. So here, T1 is greater than T2. Moreover, there is friction in this direction, and friction will have same value because mass in the two cases are same, and the friction coefficient are also same. So we can say T2, sorry, not T2, T1 minus T2 minus friction is equal to net force, and that is causing motion in 1 kg block with acceleration A. So we write A. Now we put the values. T1 minus T2 minus friction is 2 equal to A. This is third equation. We have got three equations, this one, and this one. Now, we can evaluate. We can put the value of T2 or T1 in any equation. So, suppose we write the value of T2 from here in this equation. So, T1 minus, in place of T2, we write 2 plus A. Minus 2 equal to A, or T1 minus 4 minus A equal to A. So let's write it as 2A. So T1 minus 4 equal to 2A. This is another equation. And we have this equation 10 minus 2 T1 equal to A. So either we double it and add to this equation. So it will become 10 minus 2t1 equal to a, and we are doubling it. So this will become 2t1 minus 8 equal to 4a. If we add the two, we will get 2 equal to 5a, from where we get a equal to 0.4 meter per second square. When a equal to 0.4 meter per second square, then T1 will be 4 plus 2 into 0.4. So this will become 4.8 Newton. And T2 from here, T2 will be equal to 2 plus A, that is 2 plus 0.4, that is 2.4 Newton. And that's our answer. Now, let's go to next question. Next question says, if the tension in the string in the figure is 16 Newton, this is tension, here this is tension, this is tension. So T is given as 16 Newton. And we have to find out frictional coefficient mu1 and mu2. So we can consider the motion of each block. One more thing is given, A equal to 0.5 meter per second square. Now, tension is same throughout. So let's consider the motion of this 2 kg block. Suppose acceleration in this direction is A. So we can say that tension minus friction. Friction is mu1 times mg, m is 2, g is 10, is causing motion in 2 kg block 2a. Now we can put the values. So T is given as 16, 16 minus mu1 into 20 equal to 2 into 0.5. Now we simplify, this will become 1. So mu1 equal to 15 by 20, that is 0.75. Now we consider the motion of this 4 kg block. Here mg sine theta will act in this direction, and its friction and tension both will act in the opposite direction. Still, object is in motion. So we can say mg sine theta is larger than the sum of the two forces. So we write it 4 into g. G is 10 into sine 30 degree. That is 1 by 2. Here we can write for 4 kg. Either we can write the equation first. That will be better. Mg sine theta minus friction minus tension is causing motion in 4 kg block. So we are putting the values in this equation. So 4 into 10 into sine 30 is 1 by 2 minus friction. Friction in this case will be Fr equal to mu mg cos theta. Here mu2, m is 4 into 10 into cos 30 degree, root 3 by 2. This will cancel out. So mu2 into 20 root 3. So we will make use of this. So we have put the value of mass g sine theta minus friction mu2 into 20 root 3 minus tension. Tension is given as 16 equal to motion 4 into acceleration. Acceleration is given as 0.5. So we simplify. So this will become 20 minus 16, and this will become 2, and we can set this. So 20 minus 16 minus 2 equal to mu2 into 20 root 3. So mu2 will be equal to, from here we will be that will to 2 upon 20 root 3. Sorry, not 20, this is 2 upon. So 1 upon 10 root 3. We can evaluate it by putting the value of root 3 as 1.732. So it will become 1 upon 17.32, which is nearly 0.06. And that is our answer. Now let's consider next question. The friction coefficient between the table and the block shown in the figure is 0.2. Find the tensions in the two strings. Here tension is supposed T1, T1, and here tension is T2. So this will also be T2. And here friction coefficient is 0.2. Now we can consider the motion of T1, T2, and sorry, motion of 15 kg block, 5 kg block, and this 5 kg block. So let's consider the motion of this block. So it will move in this direction. So all blocks will have acceleration A. Now its weight 15 into 10. So equation will be mg. Suppose we write it as m1. This as m2, this as m3. So m1g minus T1 is net force due to which this object is moving in downward direction. So 15A. So M1 is 15 kg, G is 10. So we can say 150 minus T1 equal to 15A, equation number 1. Now, we consider the motion of M2 for M2. So here T2 minus T1 minus friction in this side, minus friction is causing motion in 5 kg block in this direction. Sorry, it should have been here. T1 is larger because motion is in the direction of T1. So T1 minus T2 minus friction will be in this direction. Friction minus friction is equal to motion of 5 kg block. So 5 times 3. So now we put the friction. Friction here will be Fr, that is the mu mg. M is 5. So mu is given as 0.2. And M is given as 5, G is 10. So 50 is this will become 5 is 10. So 10 Newton friction force is there. So we can write here T1 minus T2 minus 10 equal to 5. So this is suppose second equation. Equation number 1 is equation number 2. Now we consider the motion of this 5 kg block. So it is moving in upward direction. So tension T2 minus its weight downward. So 5 into 10 is equal to 5. Now if we add equation number, this is T1, this is T2 containing equations. So if we add 1 and 3, so what do we get? This is 150, this is 50. So 100 will be left. 100 and the minus T1 and plus T2 equal to. Here it is 15A, this is 5A, so 20A. So this is another equation. We have got equation number 4. This equation contains T1 minus T2 minus 10 equal to 5A. This equation contains 100 minus T1 plus T2 equal to 28. If we add the two equations, then T1, T2 will get eliminated. So adding 2 and 4. So we will get here 10, this is 100, other terms will cancel out. This will become 90 equal to 25A, from where we can get A equal to 18 by 5 meters per second square. Now we have to get T1 and T2. So to get T1, we put the value of A here. So 150 minus T1 equal to 15 into A. A is 18 by 5. 5 3 so 150 minus 54 will be T1, which implies T1 equal to 96 Newton. Now, we have to get T2. So, we can take this equation. So, T2 equal to 50 plus 5A. 50 plus 5A. A is 18 by 5. 5 will cancel out. It will become 68. This is, we are getting T2, sorry. So, T 68 Newton. So, we have got our values. Thank you for watching.